It's not mirroring. Hello guys, hope you are doing well. I'm kind of nervous, but I want to thank you everybody that are here today to see my talk, and I hope you can learn something today and something useful, not for bad things, okay? So let's start. My presentation is about car hacking, how I hacked my car lights with an Arduino Ekoparty 2025. It's too hard because I'm not mirroring, so here I have a lot of other things. So first, who am I? My name is Leandro. I have 21 years old. I'm a Brazilian, and I'm a member of Car Hacking Village Ekoparty and Car Hacking Village 828C. 828C is a hacker conference like Ekoparty, but in Brazil. Will be awesome if you can go there too. I'm a software engineering. I'm not security researcher or that stuff. I work with development. I'm a software engineer at EasyAccess Tecnologia. It's a Brazilian company. We work with RFID technologies. And I'm a CTF player for Volkswagen. It's a CTF team. And I'm basically a cybersecurity enthusiastic. So I just like cybersecurity and cars. And now I'm Ekoparty 2025 speaker. And here we have three pictures. The left side, it's my team it's not mine, but our team, our CTF team. In the middle, it's my coworkers, my friends from job, the software team. And right here, the Car Hacking Village 828C 2024. My friends, I think the only that was not here is Kamel, but everybody was here to the event. So let's start. Here's the agenda, what we'll talk about. First, a little introduction and some basic stuff, some needy stuff to you understand the presentation. Tools and dependencies, documentation, finding the canvas, CAN sniffer setup, sniffing, injection, then a conclusion. So let's start. My objective with this presentation is to show you guys a real example of using Canvas reverse engineering to control car functionalities. So in a real vehicle and how you can apply it. Basically teach how you can reproduce that in your home with a low cost setup with a simple Arduino and an MCP. Then finally, to make you think, how can I apply this knowledge to hack other functionalities or to explore other weaknesses in my car? The devices I used was Arduino UNO R3. I really use it for the most automation stuff and robotic stuff, and MCP 2515 CAN bus module. I will say more later. And a little attention. This project right here was performed on a 2012 Volkswagen Polo. So the process will likely be different for other vehicles. But the core principles may be similar. Always proceed with caution. Please don't judge me if you broke your car, if you damaged something. Okay, so let's explain some basic stuff to help you to understand the principle of the presentation, okay? So first, what is CAN? CAN means controller area network. So it's the network inside the car, is the car network, okay? So if the car was a body, the CAN bus will be the nervous systems. Every device, every node are connected inside the CAN bus. So these networks allows them to constantly communicate and share information with each other over a simple two-wire system. That's important, two-wire. made up of CAN high and CAN low line. So we have the CAN high wire and the CAN low wire. And here below we have a picturing show a basic example of a CAN bus network. Okay, so we have 3 nodes and all are connected with each other. So if the CAN device 1, the left side, send a message, every node will receive the message. So that's why it's important to understand what is a CAN frame. Okay, every message inside the CAN bus are CAN frame. Okay, so what is a CAN frame? So the communication over the CAN bus is done via CAN frames. Below is a standard CAN data frame, right? It's a standard CAN data frame with 11 bits identifier, which is type used in most cars. The extended 29-bit identifier frame is identical, except the longer ID, so it's the same, is for identification. The only change is the size, okay? Note that the CAN ID and the data are highlighted. So these are important when recording CAN bus data, as we will see below. So here we have a standard CAN frame, right? But only focus on CAN ID and CAN data. That's the only important knowledge that you need, okay? The other things, don't need it yet. Okay, that's a little bit harder. It's CAN bus signals, but it's important to know. The CAN bus work with differential signals. CAN bus transmit data using 2 complementary signals on 2 separated wires, making it more resistant to noises and interference, because the car have a lot of stuff inside it, like sounds and other technologies that can reproduce a noise inside the communication. So that's why CAN bus have 2 wires, the CAN high and the CAN low. So the receiver interprets the data by measuring the difference in the voltage between the 2 wires, and any noise that affects both wires equally is cancelled out. So for example, if the CAN high was affected by some noise, the CAN low will be affected at same. So the difference will be the same. So here we have the logic 1. Both wires are the same voltage. For example, 2.5 voltage. So the difference, the 2.5 to 2.5 is 0. So this will result in 1. And the logic 0 is the opposite. The wires have a clear voltage gap. For example, the CAN high have 3.75 voltage and the CAN low 1.25 voltage. So have a difference, have a gap. It will result in 0 byte. Finally, the baud rate and the bit rate is only to knowledge. It's the speed of the bit communication, okay? So the both are talking about speed, right? But the both are talking about measuring communicate speed. In this presentation, both bitrate and baud rate are used to measure the speed of data communication. So the bitrate for CAN communication. So when we are set up in our device, we need to know what bitrate is communicating in the CAN bus of our car. So to successfully read and write data on the CAN bus, it is crucial to know and use the correct bitrate, okay? All devices on the CAN network must be set to the same bitrate to ensure reliable communication. Then the baud rate for Arduino communication. For communication with the Arduino, we need to set a specific baud rate. You probably already see it in Arduino IDE. So it's essential to use the same baud rate on both the Arduino and the device reading the data to ensure the information is received correctly. Then SLCAN. SLCAN is a protocol that converts CAN bus into a serial communication line, commonly used to connect a computer to a CAN bus via USB port. So the protocol transmits CAN data as ASCII2 characters over a serial connection, like that ones or wired ones. The serial line CAN protocol acts like a translator, converting serial data from a USB connection into CAN message and vice versa. Okay, so let's start. First, tools and dependencies. In the Arduino, we need to set up our sketch and some libraries. For example, in this case, I used slcan.inu sketch to enable CAN over serial communication. As I said, serial line CAN works like a translator. So he received the CAN data and enveloped that and sent to your computer over USB connection. And the library, I use it, a ready-made library called Arduino MCP2515 library to communicate my Arduino to the MCP CAN bus module. Okay? Then terminal scripts. I use it CAN Utils macOS library. It's a library that I made that's basically a copy of CAN Utils of Linux. Okay? So if you can use Linux CAN Utils library, the process will be basically the same. So it's exactly a copy, right? But using Python CAN. Then the hardware. Here we have Arduino UNO R3, simple device and really cheap device. And here MCP2515 CAN bus module. This guy right here works like a bridge to connect the Arduino to the car. Okay, so how we can start hacking our car? The first thing, you need to find a physical place inside our car that have CAN bus wires, okay? But how you can do it? It's impossible to open all your car and try to find it. So the easiest way is to find some documentations, some useful documentations, like wiring diagram and repair manual. Okay. In this case, I found the wiring diagram of my car, not a specific my car. So it's like I found a Volkswagen Polo wiring diagram, but I have lucky and works the same. We mentioned 4 critical pieces of information. First one, my car have 2 CAN bus networks. The powertrain CAN that works with the engine, the gears, the brakes, and that stuff, and the comfort CAN network that controls windows, doors, and lights. The comfort CAN bus bitrate is 500 kilobits per second, kilobits per second, okay? So is really important because without this knowledge, it will be impossible to read CAN data because the frequency of the speed will be different, okay? Then I know that in my car will be different in your car, but you can find it. The CAN high wire color is orange-black, and the CAN low wire color is orange-brown. So my CAN bus wires are colored. Finally, I found in the documentation that my car's dashboard contains CAN wires. So here we have a picture showing, it's like a print of my document showing the CAN bus colors. Okay, so the left side, CAN low have orange-brown color, and the CAN high have orange-black color. Then start the hard part maybe, to start finding the CAN bus. So first I need to remove my panel, my dashboard, okay? So I just follow the documents, then I found my dashboard and take it out. Then I found 2 connectors. I was searching for CAN bus, CAN high, and CAN low wires. Then, when I found the green connector, I need to identify the correct wires. So we can see here a picture of the green connector, and right here we can see, it's not so good, but you can see the orange-black wire. That I know with the documentation that in my car is related to CAN bus wires. Okay, so we found it. Then you need to identify, just check the wires, okay? Identify the correct pinout. For example, if I cut the wires, like just cut it and put my jumper directly, it will work again, but I don't want to damage my car, so I just use an oscilloscope and check every pin of this connector. But that's okay. And the left side, I found the CAN high. You can see the voltage average, the average voltage, that is 3.55, right? 55 voltage. So it's the CAN high, Okay, and right here we have the average voltage of CAN low. That's something like 2 voltage. So we know we found the CAN high and the CAN low wires. Okay, at this point we found the physical place in the car that we can connect it to the CAN bus wires. So we just need to set up our CAN sniffer. This is the wiring diagram. So we need to prepare the Arduino. Upload the slcan.inu sketch inside the Arduino with the Arduino MCP25 library. Then connected the both using this diagram. So this is available. I will show you after. And a little tip. To test if your Arduino MCP2515 connection are working, you need to connect your MCP to the car. Like here we have the CAN high and the CAN low connections in your MCP. You need to connect it in your car and connect all these wires between the Arduino and the MCP, and you can open your Arduino IDS serial monitor and set your baud rate to 115,200. If you see any data being logged when your car is on, you got it. You find and you can read CAN data. Okay? So we found the physical place and we set up our device and we connect that. We need to start sniffing. So basically from this point I used the Python script from CAN utils macOS library, but you can use the CAN utils from Linux to interact with CAN. First, set up the Python virtual environment. In my case, in case of CAN utils macOS, that was built with Python. So I just need to run Python 3-m-vm to create a virtual environment. Then source vm being activate to activate this environment. Upgrade the pip. Then install all the dependencies to this library. Next, I use the CAN sniffer interactive script to sniff the CAN data. So with this command right here, Python CAN sniffer interactive, then the dev cu USB serial is my Arduino device. So it's the serial connection, okay? So I run this command to see all the CAN data is working like a Wireshark for CAN bus, okay? So with this sniffer running, the hard part begins. We need to interact with all car functionalities and try to find a pattern, un padrón. Okay, we need to understand the CAN data, the CAN bytes, and try to control it. So we need to press buttons, open doors, unlock doors, and observing changes in the CAN sniffer output. After an intense search and a hard work, I found something interesting related to CAN ID for 170. Right here I have a video. Okay. Bueno. I'm sorry I'm not a content maker. But right here I'm pressing the hazard light buttons. Okay. So we can see here in the top I'm pressing the emergency button, okay, to turn on the hazard lights, right? And right here we have the CAN sniffer running. The CAN sniffer plot a table. In this table we can see all the CAN data in my car. Each line right here is related to a CAN ID. And we have the ID and the data. So it is updating all the time. And you can see in real time the data changing. So basically I was pressing the button, the hazard light button, and checking what changed in this crazy stuff right here. And if you can see with a lot of attention, you saw a really basic, I'm sorry I'm not a content maker, but you can see a little change in the 470 byte. This video was a trash. Wait. Then, oh, sorry. We can pass to the, right here. Go to the next slide, please. Okay, so we found something interesting in the CAN ID 470. Okay, pressing, interacting with your car. You need to interact. You need to do all possible functionality. Then we found useful, something interesting in that ID 470. Then I can use other command, call it can dump. We can see the command running. Then I basically, with this command, I can make a filter with one CAN ID only. So for example, here I'm filter only for 470 ID. Then each line right here is a CAN data. So we can see here in the top side, when the hazard lights are off, the first byte is 80 when the hazard lights are off. And when I turn on the hazard lights, the first byte goes to 8B, 88888888, then 8B again. So I found a pattern. I found un padrón. Then, when we found this pattern, I can control whatever functionality in your car. This is the easiest example possible, because a light can be or on or off. Is a binary example, but you can use the same logic to control your steering wheel or your window or your doors, is whatever your car functionality your car have. Okay, so but it's kind of hard. For example, your steering wheel can be 70% for the left or 70% for the right. So it costs more to understand and find the pattern. Okay? But once we find the pattern, we can inject data. We can use can send commands to inject our functionality, our control. For example, I know it that the 8B byte right here, when the 8B first byte in the CAN ID 470, it means that the hazard lights are on. So I just imagine, if I send, when the hazard lights are off, if I send the 8B byte in the CAN ID 470, it will go on. So I just need to test it. Then I run other command, call it can send. You can use it with canutos too. So basically, Python can send dev cu.usb serial. This part, dev cu.usb serial, is the path of my serial device, of my Arduino. Will be different in your machine, but it's so chilling to find. Okay, I just need to send the message 470 ID hashtag the data. So 8B0000FF02. This other stuff, the 0000FF02, don't change anything. Don't change any time. I was interacting a lot with my car, and that stuff don't change. So I don't know why that exists, but probably have a reason. So I just need to send the 8B byte, and the lights go on. And to turn off is the same logic. We just need to send, run again, Python can send dev cu USB serial 470 80. You can see the difference. The first one I run 8B, the second one 80. So the 0 is when the hazard lights are off. Then my car turn the hazard lights off. Here I have the hazard lights are off. Then I go to my computer and run the command Python can send 408B. You can see it, 8B0000FF. Then it was sended. Then the hazard lights goes on. To turn it off, I just need to make the opposite. Send the 80 data. Send it. Then my hazard lights go off again. I will show this one because it's kind of better. Okay, I can't. That's okay. finally, you can apply the same logic, the same stuff to control all functionalities. That's the easiest example possible. You can use this example to control whatever functionality. You just need to read. Sorry, I'm going to come back. Okay, we just need to read the scan data and understand the pattern. If we understand the pattern, we can control. For example, imagine in your car, how the side lights are related to CAN ID 1. Okay, so when both side lights are off, your CAN data is 0. Then you start interacting with your car. You turn the left light on. Then you can see your CAN data goes to 1. Then you turn your right light on, and you can see your CAN data goes to 2. Then you start the emergency button, and the both side lights going on, and your CAN data goes to 3. Then you find a pattern. You can interactive. And imagine if you use some device like an SP32. You can make this network available with Wi-Fi or Bluetooth, and you can control it remotely. But have some stuff. You need to be careful, because every car have a specific CAN ID, so it's not the same. The bit rate is different, the location of CAN bus wires is different, a lot of stuff is different, but you can apply the same devices and the same structure of searching and CAN bus reverse engineering to make it work in your car. And imagine if you use an SP32 to make it accessible remotely, to turn the network available and control it with, I don't know, a joystick, a Xbox controller. You can control it. You just need to translate the commands of the Xbox controller to the Bluetooth and then to CAN, and you can control your car. But it's too specific, so you need to make it with hard work and hard time. But this example, in my opinion, is the easiest way possible to start with car hacking. Okay, it's a low-cost setup. I will show you aquí. This presentation showed a basic example of CAN bus reverse engineering to help to understand, but you can apply the same logic and same steps to control or hack other car functionalities and build your own projects. So you can find the CAN Utils macOS library in my GitHub repository. And for a detailed guide of this project, please visit my project page. So here I have the URL of my GitHub repository, and my guide is like a documentation. You can see step by step and real detailed, like this presentation. And finally, this project was heavily based on and inspired by the work of Faraday. I don't know if you know the company. And he posted a project called How to Unlock a Door with a Doogie. Doogie is the device, is a code project by Faraday. Their content is amazing, so please check it out. It will be awesome. And that's it. I don't know if you have any question. It's a simple presentation. Thanks so much. Okay, so anyone have a question or something like that? That's okay? Okay, thank you so much, guys. Thank you so much.
Hola, hola.